GCSE science, I say GCSE checkpoint science section. So here we're going to be looking at majorly the earth and space aspect of checkpoint science, and this video will cover the whole of year 7 content in earth and space. So without wasting so much time, let's move. The first thing you need to know is this is part of the syllabus content you need to know for earth and space. We need to create a plate tectonic model, look at how earthquake and volcanoes are formed, percentage of air in the atmosphere, gases in the atmosphere. So first, layers of the earth. So the earth is divided into 4 main layers. First, you have the inner core, you have the outer core, you have the mantle, then the crust is the one outside. So first, the solid inner core, which is usually made up of iron and nickel with a temperature of around 6,000 degrees Celsius. So that's the inner core for you. Then you have the outer core, is usually liquid. It is made up of the same element, iron and nickel, which we refer to as knife, using these symbols. Now, with a temperature of around 4,000 to 500,000 degrees Celsius, and the mantle, which contain molten rocks called magma. So the mantle contains magma, and convection current here moves the tectonic plate. So tectonic plates move as a result of convection current from the mantle. So convection current from the mantle makes tectonic plate to move. Then lastly here we have the continental crust. So the crust is divided into 2, continental and usually the oceanic crust. So the continental crust, made up of land, is thicker but lighter. So it has a lower density. So it is lighter. Then we have the oceanic crust, which is under the ocean. It is thinner but it is heavier, so it has a higher density. So that's it on the layer of the earth. So the next thing is, under planet Earth, the first thing they want you to know is the plate tectonic model. So how does the plate tectonic model work? So it's quite straightforward. So you find out that the solid outer layer of the earth consists of the crust, which we've just established, and the upper part of the mantle. So here, the surface here of the earth is the crust, which is made up of both the continental and oceanic in this case, because this part is the oceanic, while here is continental. Now, beneath the oceanic and continental crust, you have the magma, which is this part of the magma forms, you have the upper mantle. So why do tectonic plates move? The plate tectonic model now. You find out that the solid outer layer of the earth has tectonic plates that move. The tectonic plates move because of the magma flow in the mantle. So take note of this. This comes out a lot in checkpoint. Why do tectonic plates move? Tectonic plates move because of the magma flow in the mantle. Now, what are the events that occur at plate boundary? So a plate boundary is where 2 plates meet. A plate boundary is where 2 plates meet. So the question now is, what are the things, the event that can happen at plate boundary? 1, fold mountain, earthquake and volcanic eruptions happens at plate boundaries. Now, the next thing is types of plate boundaries. There are 3 major types of plate boundaries you need to know. 1 is the constructive plate boundary. As you can see from this diagram, a constructive plate boundary is a plate, is where the plate moves apart from each other. So the plates are moving away from each other. Now, this will create a gap. So as they move away, it creates a gap here. And volcanoes magma from the mantle, there is magma here. Magma from the mantle can easily escape through the gap to the surface, leading to volcanic eruption. Now, we also have 1, that's 1. 2, the destructive plate boundary. Another name for destructive plate boundary is what we call the convergent. While for constructive, we also call it the divergent, because it's divergent. Now, at a convergent or destructive plate boundary, you find out that the plates are moving towards each other based on the arrows there. So you find out that the heavier oceanic plate, I told you the oceanic plate have a higher density. So this is oceanic and this is continental. So the heavier oceanic plate move under the continental plate because it is lighter. So it moves under, and this point where it moves under is what we refer to as the subduction zone. So moves under, and as it moves under, it moves into the mantle. So it will now melt and erupt, causing volcanic eruption. Also, moving towards each other at this point will lead to friction because both of the plates will be rubbing each other. And that friction will make pressure, will lead to buildup of pressure. Then once the pressure is released, it causes an earthquake. So within a destructive plate boundary, you can have both earthquake and volcanoes. Now, conservative plate, this is where the two plates slide past each other, moving in opposite direction like this, side by side. So the plates slide past each other, and this will lead to friction, the buildup of pressure, pressure release, causing an earthquake. That's it. So next is fold mountains. How is fold mountains formed? Fold mountains are formed on destructive plate boundary also. Remember, destructive plate boundary is when they move towards each other. Now, how? Where two plates collide. So as two plates collide, it can, when a continental plate and an oceanic plate meet, the oceanic plate is forced downward while the continental plate is crumpled and folded upward. So this crumpling and folding of upward here is what lead to fold mountains. Now, this is between oceanic and continental. Sometimes you can have when two continental plates collide. So two continental plates move towards each other. So none of them will sink because if it is continental plate, both of them have the same density. So as they move towards each other, none is going to go down. So as both of them meet, you find out that all what can happen because of the force, they'll begin to fold and lead to what? A fold mountain. So both push against each other, causing rocks to buckle and fold, forming huge mountain ranges. Example is the Himalayas. Now, composition of clean, dry air. What is the composition of clean, dry air? First, this is the whole composition of air. So nitrogen makes up 78%. Nitrogen makes up 78%. Oxygen makes up 21%. So 78 plus 21 will give you 99%. So the other 99% are made up of other gases like argon, carbon dioxide, or krypton. That's all. So about 70% nitrogen, which is the largest in the atmosphere. And it is very important because it reduces the combustion or the reactivity or the reaction of oxygen. So oxygen itself is 21% and is used for combustion. So without oxygen, no form of burning will take place. Then the other gases are things like carbon dioxide makes up 0.04%. Then you have argon, krypton, and some other noble gases. So that's the composition of the atmosphere. Now, changes in air composition. Remember, the air composition is nitrogen gas is 78. We have oxygen is 21. We have other gases like carbon dioxide is 0.04, and you have krypton and other noble gases. Now, the composition of the atmosphere also changes. And why will the composition of the atmosphere change? One is pollution. Things like human activities like deforestation, burning fossil fuel will increase the amount of carbon dioxide in the atmosphere. So can release gases like carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen oxide, which can cause problems like climate change, acid rain, and health issues. Now, we also have natural emissions, so pollution and natural emissions from like volcanic eruptions. So if volcanoes erupt, if there is things like forest fire and decaying plants and animals, all these will help to release gases such as carbon dioxide and methane, which will now change the composition of this gas within the atmosphere. Next, you need to know is the water cycle. Water cycle, so you find out that the total amount of water that has been on Earth, it has not changed. The only thing that changes is the state in which they are at that time. So at certain point, the water is under the ground, at certain point it's in the cloud, at certain point it is as ice in glaciers. So this, for your syllabus, this is all what they need to know. So you should, there are other aspects within the water cycle, but for checkpoint year 7. Now, first, you can start anywhere, but just follow the arrows. Now, these are waters in possibly the rivers. You have waters in rivers, and if there is sunlight, you find out that this water can easily evaporate. So what is evaporation? Evaporation is the conversion of liquid water into water vapor. So the water vapor will now move into the atmosphere, and as the higher you go, the higher, the cooler. The higher, the cooler. So what will now happen is, as you go high, this water vapor will now cool and condense. So condensation is now when the water vapor turn back into liquid water. That's condensation, the process which convert water vapor into liquid water. Now, once it becomes liquid water in the atmosphere, that is what will lead to the formation of cloud. So cloud is condensed water, it is liquid water. So the water now, once it's very large, it falls back to the earth as precipitation. So precipitation is the process by which water falls from cloud. So this can either come down as rain, it can be snow, it can be hail, whichever form, but they are all precipitation. Now, once you get to the earth's surface, there is what we call the water runoff. That is the flow of water on the earth's surface. So the flow of water on the surface of the land, and it flows into rivers, into lake, into sea. Now, there is also groundwater. So some of this water, as it flows, it also sink into the soil and into rocks. So the ones that sink into the soil and into rocks through a process called infiltration and percolation, you don't need to know that for this checkpoint. They get down underground. So once you reach underground, you find that some water soak into the ground and is stored in underground in the soil. Some also flow under the ground. So that's it about water cycle. Next is how planets form. How are planets formed? So I broke this down into various steps. So first is formed from cloud of dust and gas. So you find out that this is the first thing, cloud of dust and gas. So long ago, there was a huge cloud in space made up of dust and gas. So this cloud is not made up of liquid water, it's made up of dust and gas. So gravity pulled them together. So gravity make the particles of this dust and gas pull together and now clump. So here is the dust and gas. So gravity is now pulling them together. So once gravity pulls them together, small lumps are formed. Now this clump become bigger clump called planetesimals. You don't need to know that. But yeah, if you can, you should. But first, gravity pulled them together, small lumps are formed. Then later, continuous gravity will now lead to bigger lumps called protoplanet. The lump keep crashing and joining, growing into protoplanet. So that's how planets are now finally made. So first, cloud of dust and gas. 2, gravity pull this cloud of dust and gas together to form small lumps, and continuous pulling of this dust and gas together will now lead to larger or bigger lumps, which forms the planet. So that's how planets are formed. It's formed from dust and gas pulled together by gravity. So if you ask how is planet formed, you say it's formed from dust and gas pulled together by gravity. That's it. Then next, gravity in the solar system. Gravity in the solar system. So what is gravity? Gravity is a force that pulls objects towards each other. So there's a lot of gravity in the solar system. So the sun here, so you find that the sun is very massive, so it has a strong gravitational pull. So the sun have a strong gravitational pull. So you find out that this gravity keeps the planet moving in its orbit. So it is the gravity from the sun that keeps all the planets in place and enable them to move on their orbit around the sun instead of flying into space. So the planet cannot leave this orbit and move into space because of the gravity from the sun is pulling them together. In the same way, the gravity of the planet keeps the moon orbiting around them. So gravity of the sun keeps the planet orbiting around it. Gravity of the earth keeps the moon orbiting around it. So simple. Now, how are tides? How tides are formed? How tides are formed. So tides happen because of gravitational pull of the moon and the sun on the earth. That's all. That's how tides are formed. This creating regular rises and fall in sea level. So if you are asked how are tides formed, tides happen because of gravitational pull of what? The moon and the sun on the earth's ocean. So once that happens, it will now create regular rises and fall of sea level. Then lastly, for year 7, they need you to know about the solar and also the lunar eclipse. So a solar eclipse happens when the moon moves between the earth and the sun. Simple. So the moon moving in between the earth and the sun lead to solar eclipse. So the moon blocks sunlight, casting a shadow on the earth. That's it. So the moon is in between the sun and the earth. So the moon will block sunlight and cast the shadow on the earth. While in solar eclipse is when the sun or when the earth itself is between the sun and the moon. So earth moves between the sun and the moon. So what will happen? You find out that the earth's shadow falls on the moon in this case. And this makes the moon look darker or reddish in color. So that's what sometimes lead to what is called the blood moon. So thank you. We are done with year 7. So possibly the next class we'll look at the year 8 content on earth and space.